Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 13 problem of this month on LeetCode, problem number 3066. Minimum operations to exceed threshold value 2. Okay, so let's understand the problem statement first. So you are given a zero indexed integer array nums and an integer k. Okay, in one operation you will take the two smallest integers x and y in nums. Then we have to remove x and y from nums, and then we have to add minimum of x and y into 2 plus max of x and y anywhere in the array. Okay, note that you can only apply the described operation if nums contains at least two elements. Okay, and we have to return the minimum number of operations needed so that all elements of the array are greater than or equal to k. Okay, so let's understand this problem statement with an example here. So this is my nums array given to us, right? K is equal to 10. Okay, so right now the top two smallest elements from this nums array is 1 and 2. Okay, so let's say x is 1, okay, and y is 2. Okay, then we have to apply this formula. Okay, so we have to remove this 1 and 2 from my nums array. Then we have to apply this formula. Okay, so minimum of x and y is 1, multiply it with 2, and then we have to add max of x and y, which is 2, so I will get 4. So I'm going to add this 4 anywhere in my nums array. Okay, so I have added this 4. Okay, so this is nothing but my operation 1. Okay, operation 1. Okay, so right now see, the top two smallest element from my nums array right now is 3. Okay, let's say x is 3 and y is equal to 4. Okay, so x3 na smallest. Okay, so this is less than 10. Okay, so we have to apply again this formula. So minimum of x and y is 3 into 2 plus max of x and y is 4. So I will get something around 10. Okay, so remove this 4 and 3 and just add 10 here anywhere in my nums array. Okay, so this is nothing but my operation number 2. Okay, so now if you see, the topmost smallest element is 10. Okay, which is equal to 10. Okay, so right now if you see in my nums array, all the elements are greater than or equal to k. Okay, so we have to stop. So how many operations we did? 2, right? So 2 is going to be my output here. Okay, so now you can go over this explanation. So in the first operation we remove elements 1 and 2 and then add 1 into 2 plus 2 to nums becomes equal to 4, 11, 10 and 3. Okay, and then in the second operation we remove elements 3 and 4, then add 3 into 2 plus 4 to nums becomes equal to 10, 11 and 10. Okay, now at this stage all the elements of the nums are greater than or equal to 10, so we can stop, right? So it can be shown that 2 is the minimum number of operations needed so that all the elements of the array are greater than or equal to 10. Okay, clear? Now see the constant size. So constant size is very large. Okay, so definitely I can't apply brute force. Okay, so it's not like first I start with this index and then I find the smallest element, then I find the second smallest element, then I remove the two elements from the nums array, then add the new value and then again do all that stuff. Okay, so it's not right. Okay, so I'm not going to apply the brute force. Okay, and here see, a particular number can be very large. Okay, 1 to 10 to the power 9. Okay, so whenever we are going to apply the formula, so maybe results go out of bound for the integer type, so I'm going to use long here. Okay, so this is long. Okay, and we need the smallest elements every time. Okay, when so I need a data structure now. So in the data structure, whenever I'm going to insert the elements, so the minimum elements should always go to the top. Okay, so here what I'm talking about, I'm talking about priority queue, right? Min heap. So we can use min heap here. Okay, so this is the first thing that comes to my mind when the problem statement says that we need the two smallest elements every time whenever we are performing any operation. Okay, so now what I'm going to do here, in this nums array, initially we have elements like this: 1, we have 2, then we have 3, and then we have 10, then we have 11. Okay, initially. So what I'm going to do, I will check. Okay, so I will check that my priority queue has size greater than 1. Okay, only then I can apply the formula there, right? X and Y. Okay, only then I have X and Y if my priority queue size is greater than 1. Okay, so I will check if my priority queue size is greater than 1. Yes, and the topmost element, if it is smaller than 10, so yes, only then I have to do now. If the topmost element is equal to 10 or greater than 10, then we don't need to apply, right? So if we just need to make sure that all the elements are greater than or equal to k. Okay, so right now this is not the case. So what I'm going to do, I'm going to remove 1 and 2 from the top of it. Okay, and then I'm going to add the new element, which is 4, to my priority queue. So 4 is going to come here and 3 is going to come here. Okay, okay, automatically. Right now again I will check priority queue size is greater than 1, and the topmost element is smaller than this 10. So I'm going to remove topmost 3 and 4, and here I'm going to add the result, which is 10. Okay, so I'm going to add 10 here. Then again I will check. So priority queue size is greater than 1, we are good, but here the topmost element is equal to k, so we have to stop here. So how many operations we did? 2. Okay, I will side by side maintain the count and I will return that. That's it. Easy, right? So now let's write the code. So it's very easy. Okay, so here create one priority queue, and here we have to just specify long. Okay, and here pq is equal to new, let me just maximize the size, new priority queue. Okay, and then just iterate over all the nums. Okay, elements. So int num in the nums. Okay, I'm using for each loop, and here I'm just going to do priority queue dot offer. And right now all the nums are numbers in type, so I have to change them to long. So here I'm going to write long, and here I'm just going to write num. Okay, that's it. Now create one variable int count is equal to 0. Then after that we have to just run one while loop, while priority queue dot size. Okay, I will make sure that size is greater than 1. Okay, and priority queue dot peak. Okay, priority queue dot peak. Okay, so it should be less than k. Okay, only then we have to apply the formulas. Okay, so we have to take top two elements. Okay, so first x, so here I'm just going to write pq dot poll. Okay, and then we have to take y. Okay, so y is going to be pq dot poll. Okay, so here first we are removing x, so definitely it is going to be the smallest one. Okay, then we are polling this y, so definitely it's going to be the second smallest. Okay, by default. Right now we have to just apply this formula. Okay, this formula, and here add that element to the priority. Okay, pq dot offer. So here x is going to be smallest. Okay, so no need to check min of x and y. So x is going to be smallest, only x into 2, and then here max of x and y, which is just y. Okay, so I can simply write y, and then side by side I'm maintaining the count. Okay, count plus plus, and here we have to just simply done count. That's it. Okay, that's it. So easy, right? Now let's run it and see if there are code issues. We'll try to fix that. So the test case has been accepted. Let's submit it. So see, our solution is accepted, right? So, and the time complexity is we are using priority queue and we are iterating over all the elements in my nums array, so it is going to be off and login. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.